So we are going to look at modeling with quadratics. So the first thing we're going to look at is if they gave us more information about points along the quadratic. So we already talked about this once in class where they gave us some information, usually that gave us at least one piece of our equation, and that we could use the points then to plug into the equation to find other pieces of information. The difference here is that they are not giving us any pieces of information. Instead, just points. So nothing extra in addition to that, but we're still going to use the points how we would use them before, plugging them into the equation, hoping to see that other information that we need. So first recall that standard form of your equation is y equals ax squared plus bx plus c. And then if we look at the points, we're going to plug in like 0, 0, negative 1, 1, and 1, 5. Now remember, each point is an x and a y value. So you would plug them into x and y simultaneously, those values, and hope that you would learn something about a, b, and c. So 0, 0 is kind of a super friendly point, very nice, so to speak. And the reason is you can see that when you're plugging 0 in for x, what's happening is you're eliminating these terms of the equation, which is making it really easy to just find c. So in this case, we would immediately find out that c is 0. Now, you can either use that piece of information later, or you can use it with the equations that you're about to plug into. So when I go to plug in these next points, I have my y value, and I'm going to replace my x value as well. And I can replace c with 0 if I'd like to make it simpler. So you'll see here I get the equation that 1 is equal to a minus b. Now, that equation alone cannot help me, but maybe I can use it later with some other information to find a or to find b. So the next thing I'm going to look at is I'm going to look at the point 1, 5. So that's with 5 being the y coordinate and 1 being the x coordinate. And again, c is equal to 0, and this gives me that 5 is equal to a plus b. So neither of these equations can be solved on their own. But if I use these equations together as kind of a system of equations, then I can use substitution or elimination to find my a and b values. So at this point, I'm going to take both of those equations. So 1 equals a minus b, and 5 equals a plus b. And because we have a minus b and a plus b, they're already set up for elimination. So I would get 6 is equal to 2a, and the b's would cancel out, telling me that the a value is equal to 3. And then I could go ahead and plug that a value in to one of the equations to solve for b, which would come out to be 2. Now, my job was to write an equation of a parabola in standard form, so I need to go back to this equation and use my c value, my a value, and my b value to write my final answer, which is going to be y equals 3x squared plus 2x plus 0, or I don't need to write the plus 0. So that's my final answer for my equation. The next example we're going to look at has to do with what we were doing with our ball toss problem. So we're going to talk more about interpreting these results in class. But here you'll learn a little bit about how to use the calculator to help you, like we did with our linear data as well. So the first thing we're going to do is we're going to look at this data, and it says it shows a meteorologist's predicted temperatures for Baltimore, Maryland, and it shows them in comparison with time of day. Now, if we're going to make a scatter plot of this data for time of day, we can't number it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. That's going to be confusing because the numbers are going to repeat itself. So what we're going to do is we're going to do time on the 24-hour clock, or basically how many hours it away from midnight it is. So 8 a.m. would still be 8. 11 a.m. would still be 11. Okay. At 12 noon, that would be 12. And then 1 p.m. would be one more after that, so that's going to be like 13. So our 2 p.m. we're going to think of as being 1,400 hours. 5 p.m. we would think of as being 1,700 hours. 8 p.m. we would think of as being 2,000 hours, and then 11 would be like 23, okay, out of 24. So that's what we're going to think about those numbers so that we can scale our x-axis incremented upward, basically from 0 to 24, because that's how many hours go in a day. So now our job is going to be to go ahead and put this calculator into the data, and notice our job is to come up for a quadratic model for this data. Now, a model for your data is the equation that you guys would come up with. This time, it specifically tells you that you're looking for a quadratic equation. But even if it hadn't told you that, you're going to be able to see by the data that this doesn't look the same as your calories and fat gain scatter plot, that it looks a little bit differently, and that's why we use a different curve. So we're going to go ahead and we're going to go to the calculator. And on the calculator, we're going to plug in your data. So as usual, if you want to plug in data, you go to Stat, and then you choose Calculate. Now we have our lists. If the stuff in the list is not what you want, you should scroll up to the top and push Clear on the list. Not Delete, but Clear, and then Enter, and all the data from the list will be gone. And you can do that to clear out any lists that you don't want. If you want the data that's in your lists, because we're going to use it again on Monday, then you could enter your information in other lists, like L3 and L4, and you could use those lists. Okay? So for our data, our hours that we were using were started at 8. So we have 8. So I'm just going to enter all the data that you guys saw in the chart, and you should do the same on your calculator. All right, and I'll just make sure I have 6 data values, which is what we saw in the chart. And then I'm going to make sure I get 6 data values that match up with that in the temperature column. And then I'm just going to enter all those temperatures. So you guys can do the same on your calculator. And 56. And make sure that they correspond. So we have 6 data entries in each column. Now, I want to see the scatter plot of this first. Okay? So what we're going to do to see the scatter plot is we're going to go to your y equals, and if there's any other equations in your y equals, there's not in my calculator. But if there was in yours, you can clear them out. Or if you want them, but you just don't want them right now, put your cursor on the equal sign and press Enter so it's not bold anymore, and then it won't show up on your graph. Then I'm going to go to second y equals, which takes me to stat plot instead. And in the stat plot, I'm going to turn a plot on with all of my data. So I'm going to press Enter in one of the stat plots. I'm going to turn it on. I'm going to make sure it says that it's a scatter plot, whichever lists my x and y coordinates are in, and whatever mark I want it to make. Then go to Zoom and choose choice 9, and you can do that by scrolling down or just by pushing 9. And it's called Zoom Stat, which is appropriate because we're going to have it zoom to the values in our stats. So you'll see that if we look at the curve, okay, this definitely doesn't look linear because part of it would start going up and then part of it would start going down. And that's how I would know to use some other regression line. Okay, some other type of curve to describe the data besides a line. And we can use any type of curve. Because this curve tends to go up, curve around, and come back down, then we're going to use a quadratic curve to describe this data. So we're supposed to obtain the model for this. So to do the calculation, we're going to go back to Stat. We're going to press Stat and Calc. In Calc, there's lots of different regressions and data things you can run. We're going to choose choice 5, which is a quadratic regression, because I feel like the data is shaped somewhat like a parabola, which is a quadratic curve. So I'm going to press Enter. And again, you might want to tell your calculator which lists your data's in, especially if you use different lists besides L1 and L2. And if you want it to include it in the graph, put another comma or in the place where it says store regression equation. Choose Y1 and do that by going to vars, arrow over to yvars, choose function, and whichever spot you want it to be in. Now, if you already have something in Y1, you might want to put it in Y2 or something like that. Once you've got all of that, press enter. Okay. And you can see the A, the B, and the C values that it calculated. Now, on our note guide, it said to record these values to the nearest hundredth. So for A, we're going to use negative 0.16, for B, 5.14, and for C, 21.6, based on how that would round. If we want to see it on the graph, we'll go ahead and we'll press the graph button. And then you can see how well this curve describes your data. And you can see that a quadratic regression worked pretty well for this data because it tends to go along the trend of the data. Okay. Now we're going to go back to our note guide and put our equation in that we found. So it asks for the quadratic model, and it says to round to the nearest hundredth, like we were talking about for our A, B, and C values. So we're going to have negative 0.16 as our A value. So that's the coefficient of x squared. 5.14 for our B value, so that's the coefficient of x. And 21.6 for our C value, so that is our constant. So there is a model or an equation that we feel represents our data pretty strongly. Okay. Then it says use your model. And again, when it says model, it's referring to the equation that we built based on this data to predict the high temperature for the day and what time does the predicted high temperature occur. If you look back at our calculator, you can see where the high temperature occurred. Okay. It seems to be occurring somewhere up here, okay, at the top of our curve. And so we really want to know what that is. So the height here, remember y values were temperature. This is going to give me wherever the high temperature. And then remember the x values were the time of day. So the x value is going to give me the time at which the high temperature occurs. So this is like in class when we were talking about maximum value versus when the temperature occurs. Okay? So how are we going to find that? So it is a vertex point. Our maximum and minimums always are. So we can use our calculator to help us find our vertex point. So a reminder of this calculation. In the graph, we would go second, and we would go trace, which gets us to the calculate menu. And we're trying to calculate a maximum in this case, based on the fact that a vertex is always a maximum or minimum. And for our curve specifically, it would be a maximum. Now remember, it asks us for the left bound. The left bound means, can you give me a point that you know that is to the left of your maximum value? So if you're on what you think is the maximum value, scroll a little to the left and press enter, and it kind of marks the boundary. Then it asks for a right bound, so then make sure that you scroll to the right far enough that you are to the right of where you think the vertex is, and press enter. And then it says guess, and press enter again. So it tells us our maximum is basically at 16.00, so we'll just call that 16, and 62.8. So we're going to take that information back to our question and see if we can answer the question that they were asking us about. So they said, use our model to predict the high temperature for the day and at what time the high temperature occurs. So we just looked at the vertex of the graph, and we got 16, 62.8. So this is like our x and our y, but think about what those corresponded to us in this problem. X was time, and y was predicted temperature. So when it asks us to predict the high temperature for the day, we would be using our y value, okay, because that's our predicted temperature. And so we would assume, based on our model, that the high temperature that we would predict for a fall day here would be 62.8 degrees. The next thing it asked is, at what time does the predicted high temperature occur? Notice that our x value representing time was 16, and we used that as hours after midnight, okay, or like the 24-hour clock hours. So we would assume that this high temperature of 62.8 would occur at 1600 hours. So 1200 would be noon, and we're 4 hours beyond that. So we're looking at 4 o'clock p.m. when we expected to hit this high temperature that we predicted. Okay? And that doesn't seem so off. If you look at our chart, the highest temperatures were 63, occurring at both 2 and 5 o'clock. So this kind of fits with our data and seems to make sense. So when you guys come back on Monday, what we're going to do is we're going to finish running the data for the ball toss experiment that we did, and we're going to answer some questions about what our prediction looks like, maybe how good of a job it does predicting, and different values that it can predict for us. Okay? And then in addition to that, we'll answer any questions you guys have on homework 4, which was the homework you did when I was not here. And then any other questions you might have about today's lesson. And then on Monday night, you guys will do homework number 5, which you could probably do based on the 2 examples you just saw. Okay? So enjoy the rest of your weekend, and I will see you guys on Monday.